Okay, so this question is a little bit more tricky because it involves 3D coordinates. Now, normally we just talk about x and y coordinates. So the graph would just look something like that. So that's the x-axis and that's the y-axis. But this time, as well as having the x like that and the y like this, you have an additional dimension, which is z. So it's x and y, which is flat, and then the z, if you like, comes out. So when they say B is a point with a coordinate 12, 4, 0, well, what that means is it's 12 along the x, is up 4 along the y, sorry, 4, and 0 outwards. So if you go 12 along the x, that will be there. And then if you go 4 up, it's there. And then it doesn't come out on the y, so it just stays there. So that's B. And then it says G has a coordinate of 0, 0, 3. So it means 0 along the x-axis, 0 along the y-axis, and then 3 along the z. So 0 along the x means I don't move at all this way. 0 along the y means I don't move at all that way. But it only comes up by 3. So this is the coordinate of z. So I've shown the coordinate for B, and I've shown you the coordinate for z. Then they said calculate the distance between the coordinates B and G. So from the top back corner coming all the way down to the front corner like this. Okay, so that's what we need to work out, that length. So let's tidy up a little bit. So we want to work out this red line, which is between B and G. Now if you think about it, B to G is the diagonal. So it's a diagonal like that. Oops. It's a diagonal like that. And B to E, this comes down like this. Now think about it, this is the back corner of this cupboard, if you like, or this room. And then along the floor diagonally you've got this E to G, which is this bit there. So that's B, that's E, and that's Z. So we have actually a right angle triangle, because this is the floor, along the floor, and this is the vertical height. So it's best to work out this length here, the Z to E first. So Z to E is a bit on the floor, which again we could use Pythagoras, because this here is a right angle triangle. If I draw this out, it's flat on the floor, but if I make it come up and become a triangle, you've got E, that corner there is this corner here, F is here, and Z is here. So you've got another right angle triangle. Now from here to here is 12, because they told us B was 12 along the x-axis. So however far B has gone along the axis, F has gone the same distance. So this is 12. And this length here is the same, it's come out on the z-axis, same as G, which is 3. So this bit here must be 3. So to work out this length on the floor, this diagonal on the floor, we will have to do 12 square add 3 square is equal to the length EG square, the bit on the floor, EG square. So 12 square is 144 plus 3 square, which is 9, is equal to EG square. So 144 add 9 is 153. So 153 is EG squared, but we just want the length EG. So EG would actually be square root of 153. So EG is the square root of 153. Now normally we would go and get decimal and whatever, but in this case we're not. So we've just worked out the length EG is square root of 153. And I'm going to leave it like that. You'll see in a second why. So now we know this length is square root of 153, and we know that this will be 4, because along the y-axis B went up by 4. So if we take this, so this triangle is 4 up, and the base of it, which is this, is square root of 153. So we have to work out this length here, b to z. So to work out this length here, z is so I've just tidied it up a little bit. So this length here is actually this bit on the floor diagonally, which we worked out was the square root of 153. So g to e, the square root of 153, and e to b is 4 because we know along the y-axis it went up by 4. And we have to work out from b to g. Now again, this is Pythagoras theorem, so if you do that square plus that square. Now this is the reason why we left it as square root of 153, because the nice thing is, if you square that, it just becomes 153 anyway. So 153, so I've done this squared, and it's 153. 4 squared is 16, and that would be equal to the square of GB square. So what's 153 add 16? That's 169. So 169 is the square of 169 is equal to GB square. But we don't want GB square, we just want the length G to be. So we've got square root 169. And what's the square root of 169? Is 13. 13 is equal to GB. So the length GB is 13. Now this was a bit tricky. If you don't understand that, go right to the beginning of the video and watch it slowly again. We had to do Pythagoras twice. Once we had to do Pythagoras using this short side and this short side. When we squared these two, added up and square rooted it, we got this long side on the floor, which was diagonal. And this diagonal happened to be, as you can see here, the short side, the base of this triangle that we're really interested in. This was the height of the triangle, so the longer side there is what we're working out. So that's why we did the square root of 153 squared, which was 153, 4 squared, which was 16. And when we added that together, we got 169. So 169 is GB square. So when we square rooted it, we got 13. So GB is equal to 13.